I've lost my mind doing this game, yeah. Like Vincent van Gogh. He dedicated his life to his art and lost his mind in the process. That's happened to me.
Alright, and now just to give a breakdown on the space and time complexity for a following solution is that the time complexity for the solution is going to be O of n plus m, where n is the number of nodes and m is the number of edges in the graph. And meanwhile, the space complexity is going to be O of n, where n is the number of nodes, as we use additional space for the adjacency list and the visited array. So yes, this was number of connected components in an undirected graph. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. All right, it passes all the test cases. Let's submit. All right, and now just give a breakdown on our following solution that we have in terms of the space and time complexity. The time complexity for our following solution is going to be O of V plus E, where V is the number of nodes, vertices, and E is the number of edges in the graph. And this is because the solution performs depth of search traversal on the entire graph. Meanwhile, the space complexity of the solution is O of V, where V is the number of nodes, vertices in the graph. And this is because the solution utilizes a hash map to store the mapping of original nodes to their clones, which can contain at most V entries. And so yes, this was clone graph in C++ for the Blind 75. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. Just to give a rundown on our space and time complexity for our following solution is that for our following solution, the time complexity of building the graph is actually going to be O of the absolute value of E, where the absolute value of E represents the number of course dependencies. In the worst case, we iterate through all the dependencies to build out the graph. And the time complexity of our depth first search as well as going to be O of V, the absolute value of V, plus the absolute value of E, where V represents the number of courses, which are the vertices, and E represents the number of course dependencies edges. In the worst case, we visit each node and traverse each edge once. So overall, our course, our time complexity is going to be O of V plus E, the absolute value of V plus the absolute value of E, which is overall simplified to O of max of the absolute value of E and the absolute value of E. While meanwhile, the space complexity is going to be O of V plus E, representing the vertices and edges as well, indicating the number of prerequisites as well as the number of edges within the directed graph that we have. So we have the course dependencies and the prerequisites as well to be able to check if we can actually take these courses. So yes, this was course schedule in C++. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. Look at the following example we have over here between our input and output. I actually have a drawing to be able to show you folks exactly the relationships between the input and our output to help further break down the question. Alright, so just to be able to give a breakdown on the relationships between our input as well as our output, just drawing out accordingly over exactly how we can understand the relationship between the two, is that for one, we are given a matrix, is that in this matrix, we always just need to figure out the following coordinates that we have. So starting from 0, 1, 2, 3, and 4, and then we have 0, 1, 2, 3, and 4. And I also drew out the matrix accordingly without the rest of the columns. If you want to take a screenshot of the following recording or the drawing, feel free to do so at the same time. So looking at the relationship between the list of outputs that we have, it looks like the following problem wants us to return a list of coordinates where water can flow in from the Pacific Ocean all the way to the Atlantic Ocean. And to discern that relationship, we need to figure out. So if we have 0 and 4, so we start from 0, 1, 2, 3, and 4, we get this coordinate with the following height of 5. And the problem also specifies, I'm also going to highlight over here, the island receives a lot of rain and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. So we have those two accordingly. So our question is, in particular, is that while we are scanning through the rest of our matrix right here, we need to ask ourselves, can each cell with respect to its height flow from one cell to another? Well, if we were to look, for instance, understanding between 0 and 4, we have 5 over here, where it's flowing in from the Pacific Ocean to the Atlantic Ocean. And can it flow into each other? Yes, we already know that because it already connects accordingly, and it has a respective height of 5. But then we also need to ask ourselves, for its neighboring cells, can 5 also flow into 4? Well, the problem specifies the neighboring cell's height is less than or equal to the current cell's height. So, can the water flow from this cell to this cell? Well, we know that 5 is going to be less than 4 on its height, so yes, we can. And if they are equal, so we figure out the less than or equal, water can flow between each other. So is it less? So if we were to expand on 4 and 4, for example, can 4 flow in to 4? Well, yes, it can, because they are equal to each other. So this explains this relationship that we have right here. We are able to expand upon this even further if we were to even look at the cells that cannot flow from one to another. So say, for instance, we have 1. Can 1 flow into 3? Well, no, it can't. Can 1 flow into 2? No, it can't. So that's why this coordinate 0, 0 is not accounted for accordingly. Instead, if we were to figure out exactly where the Pacific Ocean flows all the way to the Atlantic Ocean, that is the relationship that we need to discern throughout the rest of our input and output accordingly. And so if we were to expand this even further to 1 and 3, we have our coordinate 1. We go down starting from 0, 1, 2, 3. We have this one, this coordinate over here. We already know that, hey, these two are the exact same, and the Pacific Ocean's here, the Atlantic Ocean's here, so it flows accordingly. And then, since 6 as well can also flow into 5, since it's less than, we know for a fact that 6 can be a coordinate that connects the Pacific Ocean, starting from here all the way to the Atlantic Ocean, and so on and so forth. Same thing with 7 at the same time, because once water flows between the two cells, this can also connect to 5 accordingly. And so we have 6, 5, and then if water can flow respectively to each one. And so the method that we will be able to do to actually replicate this following solution, given the fact that we are dealing with a graph type of problem, we will either be working with breadth first search or depth first search in this case. And since we are dealing with we are trying to figure out exactly the shortest path between the Pacific Ocean and the Atlantic Ocean. Breadth first search would be the most ideal for our following problem, given the fact that we are trying to figure out the difference of distances between the two nodes that we would have. In graph and tree problems, breadth first search is the most ideal, while depth first search, on the other hand, focuses more on connectivity and depth of a following tree or graph. And so, since we are focusing more on the distances between our data points, breadth first search would be the most ideal for this solution. Submit. And here we go. Okay, so just to give a breakdown on our following solution for the space and time complexity is that the time complexity for our solution is going to be O of m times n, where m and n are the dimensions of the given grid. The reason is that we need to traverse each cell in the grid at least once, and the space complexity is also O of m times n due to the need for two 2D Boolean array specific in Atlantic of size m times n to track which cells can reach the Pacific Ocean and the Atlantic Ocean. And the space complexity is also relative to the queue since we're storing everything and checking the relationships of our following cells accordingly. So yes, this was. Hang on, let me just clean this up for your folks so that way you can see the whole solution accordingly, and put this at the end. I'm gonna see if I can. Here we go. Alright, I'll submit. Alright, so yes, this was Pacific Atlanta water flow, and along with the space and time complexity for our following solution. Thanks again for taking the time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. Alright, it passed all the test cases. And submit. Alright, and it works pretty well. Okay, so now to just give a rundown in terms of our space and time complexity for the following solution, is that the time complexity for this algorithm is going to be O of m times n, where m is representing the number of rows, and n is representing the number of columns in the grid. And in the worst case, we might need to visit every single cell in the grid once if the grid is filled with land. And then the space complexity for our algorithm is O of m times n, where n, in the worst case, where the grid map is filled with lands, where depth first search just goes by the number of rows and columns multiplied together, and just continues in a depth first search type of recursion. So yes, this was Number of Islands. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. Just give a rundown and breakdown of our following space and time complexity for the following is that the time complexity is O of n, where n is referring to the number of elements in the input array. The space complexity is O of n, which is used to store the elements in the set. So yes, this was longest consecutive sequence. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put in the comment section. And as always, take care. Cheers. Bye-bye. Thing. Okay. If I can. There we go. That's better. Okay, so just to give a breakdown in terms of the space and time complexity for our following solution, is that the time complexity for our solution is going to be O of C, capital C, where capital C is the total length of all the words in the input list added together. And the reason being is this is because we might process each character in each word, but the space complexity, on the other hand, given the fact that we are going throughout the rest of our array and then scanning it a couple times, it's actually going to be surprisingly linear, even though that we have a queue contrary. The reason being is because it's going to be O of 1 or O of u, where in the case where we can consider the space complexity where given the fact that we are only using 26 English letters, the reason being is that we are just scanning throughout the rest of the characters that we already have accordingly when we have created our in-degree list, because we just have 26 characters, which is why the space complexity is pretty efficient for O of 1. But since we are using unique characters, in this case relative to the problem, it's going to be O of u in this case, where it's referring to the total number of unique letters in the alien language. So it can all vary and differ, but since they're all going to be lowercase English letters, it's safe to say that it will be O of 1. And so yeah, this was Alien Dictionary using Kahn's algorithm. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. If you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye. And our solution works. So now, just to give a breakdown on our space and time complexity for the following solution, is that our time complexity is going to be O of n, where n is the number of nodes, and depth first search will visit each node once, while the space complexity is also O of n due to the storage requirement for the adjacency list and the visited array, since we're accounting for everything that has been visited and checking to see if we have, in order to detect cycles inside of our data for our given graph. And so yes, this was graph valid tree. Thanks again for taking the time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.